Next is types of services. And there's one more thing. I said navigation systems are not interoperable, which means you don't have a hardware, you cannot interoperate. But if you have a hardware, let's say your phone supports GPS, GLONASS, Galileo, Beidou, all the 4 navigation systems. When you're going from here to your friend's home, say you're using Google Maps. Sometimes you may be using GPS. Sometimes you may be using GLONASS also. Sometimes you may be using Beidou, the Chinese navigation system, but you won't know. That's because that is managed by phone software. So Google Map is not your navigation service provider. Google Map is only the map provider. They're providing the canvas. Your cursor is moving using the navigation systems. Navigation system is different. Navigation application is different. So when you're using Google Maps, you may be using GPS, you may be using GLONASS, Beidou, Galileo, or a mix of everything together. It depends on your phone's capability. Clear? Okay. Now, if you take IRNSS, you got to know that even civilians can use it, correct? Based on that, there are 2 types of services. One is standard positioning service and encrypted service. This is for the Indian navigation system. Sir, NAVIC and IRNSS are same, Pooja ma'am? Yes. NAVIC and IRNSS are same. IRNSS was the initial name, but right now we have upgraded the name as NAVIC, Navigation for Indian Constellation. You can write the IRNSS has 2 types of services. Standard positioning service and encrypted service. Okay. Next to standard positioning service, you can write open access. Standard positioning service basically means it's open access. And it is available for anyone with a receiver. It is available for anyone with the receiver. If you have IRNSS receiver, it can be on your phone or it can be on any other device. You can use the standard positioning service. You may be in India, you may be in Pakistan. Geolocation is not limited. Wherever you are present, you can use it. That's called the standard positioning service. Next to encrypted service, you can write open access, available for everyone or available for anyone with a receiver. Next, for encrypted service, you can write it is available only for authorized government agencies. It is available only for authorized government agencies. Available only for authorized government agencies. In bracket, you can write defense and planning agencies. In most of the cases, it's available for defense and planning agencies. Available for the defense and planning agencies. Have you written? Yes. So this is what we are using. This is what the military people will be using. Then coming to the coverage area, there are 2 types of coverage area. We have primary service area and extended service. For IRNSS, this is specific to IRNSS, 2 types of coverage area, primary service area and extended service area. So what's meant by primary service area? Do you see in this particular map, the blue color highlight that you see here? That's the entire coverage area of IRNSS. Is it global or regional? Very evidently, it's regional because here you cannot use, in other areas you cannot use. This coverage area itself is divided into 2 types called as primary service area and extended service area. Do you see a dotted circle here? The area inside this dotted circle will be called as primary service area, which means the coverage will be appreciable, very high accuracy will be there. Outside this dotted circle and within this dotted square, do you see a dotted square here? This region is called as extended service area. So this is primary service area. The other one is extended service area. We can write it in theory and you can go through the map later. First, for primary service area, you can write it covers primary service area, covers entire Indian mainland. Primary service area covers entire Indian mainland plus at least 1,500 square kilometer from the land borders, plus at least 1,500 square kilometer from the land borders. You understand? So it covers the total Indian mainland. When we say mainland, we are not including Andaman, Nicobar and everything. Indian mainland, plus from land border, at least 1,500. But very clearly, the statement from India, it is an understatement, because you see the map here. It is definitely not 1,500 square kilometer. No? It is much higher. It can cover almost the entire Chinese region. But we have understated our capabilities for safety reasons. Clear? Then coming to extended service area. How we are going to define extended service area is it stretches from eastern part of Africa. It stretches from eastern part of Africa to western part of Australia. That's from eastern part of Africa to western part of Australia. Eastern part of Africa to western part of Australia. Have you written this? Yes. So this is about the coverage area. Then if you take, if we talk about the satellites, no? Do you remember the classification of satellite orbits? Can you quickly take that portion? You have classified the satellite orbits based on orientation, no? In the first class. Low Earth orbit, medium Earth orbit, high Earth orbit, and then polar, sun synchronous polar, geosynchronous, geostationary Earth orbit. Yes. What is the coverage area made by GSO, geosynchronous orbit? Check it once. The type of coverage area. We have drawn a diagram, no? GSO, geosynchronous. You see an infinity loop or an 8 shape. Yes. And then for geostationary Earth orbit, the square shape, correct? Do you see an infinity loop here? Yes. Do you see one here? What is written here? GSO. 1, 2, 3, 4. The blocks, the black color blocks that you see here, those are geosynchronous orbit satellites. First, second, third, fourth. We have 4 satellites in geosynchronous orbit for the navigation purpose. Do you see the square here? The square is created by what is written here? Geostationary Earth orbit. How many Earth orbit satellites? 3 geostationary Earth orbit satellites. Initially, when we launched it, the first generation, it had 4 geosynchronous orbit satellites and 3 geostationary Earth orbit satellites. You can write IRNSS, the first generation of satellites. It had 4 geosynchronous and 3 geostationary Earth orbit satellites. So I will tell you, right now we have 8. This is the first generation. Four geosynchronous and 3 geostationary Earth orbit satellite. They'll be named as IRNSS 1A, 1B, 1C, 1D. It goes on like this. 4 geosynchronous, 3 geostationary Earth orbit. Altogether, how many satellites are there? 7 satellites. Initially, 7 satellites were there. We wanted to expand the fleet. And very recently, we sent one called as NVS-1, which was sent to geosynchronous orbit. Earlier, it was called as IRNSS. I told you, we have changed the nomenclature procedure after 2020. Now we have sent the second generation of navigation satellite called as NVS-1. Altogether, how many satellites are there now? 8 satellites, but only 5 satellites are fully functional. Remaining satellites are partially functional. They are almost towards the end of the lifetime. And some are used for messaging services. Some are able to send signals partially. It's not in full working condition. It happens because we started this somewhere in 2000. The project was initiated in 2000s. And the satellites were started in 2008 itself, more than 15 years old. Slowly, they are becoming defunctional. We will be replacing it with fresher satellites. For now, in the orbit, we have 8 satellites, out of which 5 are nominal satellites, which means fully functional. 3 are partially functional. Is it clear? Can you go to the next one? Yes. They've learned about the navigation systems. Try answering this question. This is from 2019. 2019 prelims. We have a question about IRNSS. First one, IRNSS has 3 satellites in geostationary and 4 satellites in geosynchronous orbit. Yes or no? Yes. This was for 2019 timeline. Right now, this statement may be wrong, but for 2019, this was right. First statement is right. IRNSS covers entire India and 5,500 square kilometer from the land border, 1,500 square kilometer. This is wrong. India will have fully operational global navigation system by 2019. No, it's 2024. Till now, we have only regional system. This is also wrong. The answer should be 1 only. Do you understand? But if the same question is asked right now, the answer would be none, because the first statement is also wrong, because we have 8 satellites now. Is it clear? Okay, so geosynchronous. Yes, geosynchronous. Sometimes it's written as IGSO, inclined geosynchronous. I told you, no? GSO will not be on the equator, it will be tilted. So IGSO here stands for inclined geosynchronous orbit. Can you go to the next? Any doubts in these? Yes? You can tell me. Sure. Okay. This was in 2019. Do you remember I said the trend will be repeated, correct? 2019, there was a question. 2023, it was a very simple question. Which of the following countries has its own navigation system? They're not asking global or regional, just which country has its own navigation system? Japan has its own navigation system. Clear? Okay. 2023, it was there. Maybe in some other form, navigation system related question could be there in 2025 or 26, still possible. So make sure you revise the old question papers. Okay. And this was from older UPSC question, 2011. The question is about geostationary orbit, GEO. Can you tell me which is right? First is the orbit is geosynchronous. This is true because I said GEO is also a type of GSO. Okay, so this is right. GEO is a special case, no? This is right. Second one, orbit is circular. Yes, only transfer orbit will be elliptical. Remaining orbits will be circular only. Do you remember I showed animation? That was tilted. This was also orbiting around. It was circular only. This is right. The orbit lies in the plane of equator, which means it's on the equator. It says GEO is on the equator. That's also true. This one, the orbit is at altitude of 22,000 kilometer. This is wrong because it's at 35,786 plus kilometer. But this is a very old trend because it is 22,236 miles, which when you convert it into kilometer, it will be 35,786. But right now, UPSC is not playing with units or numbers or anything. They are asking straight away from the concepts only. So anyway, this question, first, second, and third are right. Fourth one is wrong. Answer is A. Is it clear? Yes. So we have completed this. We have completed this. We're starting with a system called this Gagan, and right, GPS aided geo augmented navigation. Gagan. Okay. Have you heard about the system called as Gagan by any chance? Did Alok sir tell about Gagan system? Did he tell about Gagan system anyway? So what is the use of Gagan? I'll tell you in simple terms. When you order food on Swiggy or Zomato or anything, you'll be looking at the delivery valley, correct? When they are arriving. The most awaited one will be food delivery. You will be carefully watching how many minutes away, 13 minutes, 12 minutes, 2 minutes. You will be carefully watching. And let's say there is an inaccuracy in the food delivery valley's location. You may be a little bit upset, but still, it is not a life-threatening situation, correct? Very similar to that. Sometimes you may be navigating to your friend's home using a Google map or any other navigation system. Sometimes the cursor will freeze or the map will not respond, correct? So you may think it's a problem with your phone software, but not necessarily. Sometimes GPS itself will not send you signals properly due to different atmospheric perturbations and other problems. I will tell you about the problems here. Because of such problems, what will happen is the GPS itself will not send you signals properly. And then the navigation will restart in say 5 or 6 seconds again. You may miss a road or something, yes. But all these are civilian purposes, correct? These are manageable. But imagine a flight trying to land on the runway. And then if the GPS stops working, that's more dangerous. And then if there is an inaccuracy, say 10 or 20 meter inaccuracy, then that's even more dangerous, correct? In fact, have you heard about tabletop runways? There are runways that are built on elevated platform. Example is the Kozhikode International Airport. You see, it's built on a elevated platform. If the flight tries to touch here, but because of GPS inaccuracy, if it touches down here, what will happen? There won't be sufficient space available for deceleration, and then the flight will plunge outside. Mangalore Airport is notorious for this accident. The last accident that happened in 2019, it was because of the bad weather along with GPS inaccuracy. For this reason, we are developing our own system that can fix the GPS signal. That is called Gagan. Is that clear? It's jointly developed by ISRO, Indian Space Research Organization, and Airports Authority of India. Keep in mind, this is not a navigation system. Navigation system is GPS. Any international flight, any domestic flight, primarily they will be using GPS. But this augmentation system, it is just correcting the errors in GPS system. So that's why we write it as satellite-based what system here? Augmentation system. Augmentation is adding capacity. That's all. Clear? First, you copy these two. Then I will tell you the reasons and the working principle. First point, you're asking this or the point I told you? So it's for, no, I will tell you the theory portion for that. For now, you write this alone. Gagan, who developed it and what is the system called as? Then I will tell you what exactly it does. You'll understand. Noted this? Okay. So, before we learn how it works, the question is, who owns GPS? US. If GPS has a problem, who should be fixing it? US should be fixing it. Why is it India is fixing it using a system? Why are we spending money on this? And why are we fixing it? I understand it's for civil aviation, but someone should be mandating it or requesting it, correct? You remember the organization called as ICAO, International Civil Aviation Organization, which is a specialized agency of United Nations. This particular organization, that is the ICAO, that defines that the signal should have a particular accuracy, integrity, and also availability. Three important things. The signal should have accuracy, availability, and also integrity. To ensure this, we have to develop it. Noted? Yes. Next is why GPS becomes inaccurate. Because I said GPS is one of the most reliable system. It has more than 30 plus satellites. There are backup satellites also. If one GPS satellite is failing, before they send a replacement satellite, there are satellites that could take care on an ad hoc basis. There are makeshift arrangements. After doing all these, why it becomes inaccurate? Two reasons. See here. Do you know that the sun is emitting a lot of particles, what we call as solar particles. Now, the sun is emitting a lot of particles which are emerging towards the earth. These are dangerous because it contains protons, electrons, a lot of charged particles. When it's going to strike on us, it can lead to ionization. When I say it leads to ionization, it can also lead to cancers. In simple words, they are ionized and also they are magnetized. I'm writing two terms. They are ionized, which means they are charged particles, and they are also magnetized. These are called as solar particles. This is not the only threat we have for the life on Earth. We have the cosmic radiation. Have you heard about this? Cosmic radiation or cosmic rays. These are emitted due to different processes, including explosion of the stars, through supernova explosion and everything. So from both the sides, the Earth has threats that are emerging. How are we protected from these threats? Any idea how are we protected? Ozone can protect us only from ultraviolet radiations. It's only from radiation, but these are particles. Two important factors. First factor is, you know that the Earth is like a giant magnet, no? From the magnetic poles, the Earth is generating intense magnetic field. Because of the magnetic field, whenever the particles are approaching, no, they will be diverted towards the poles, and sometimes they will be diverted away from the earth also. This is the first line of defense. The same thing for these particles also. They will be diverted towards the poles, and some of them may enter through the poles also, but never through the equator or subtropical regions. It just reduces here. First line of defense is magnetic field of the earth. Second line of defense is the atmosphere itself, because the atmosphere is much thicker, no? Even if something enters in the polar regions, they get blocked. Let's see here, some of them are entering to the polar regions, no? They will not reach the surface. The interaction happens in the upper layer of the atmosphere. Have you seen the northern lights and southern lights? There is aurora borealis and australis. All these happen because of this. Charged particles will enter inside, but it will never reach the surface because you have atmosphere, thinner top and thicker bottom. When the particles are moving through the atmosphere, they keep on interacting, they lose energy, and you are safeguarded here. So two important lines of defense here. First is the magnetic field of the earth. Second one is atmosphere of the earth. We are sitting safely inside the earth, but how about the satellites? Satellites are located outside the atmosphere, thousands of kilometers away from the earth, correct? They will be affected by solar particles. They will be affected by cosmic radiation. This is the reason why GPS becomes inaccurate. There is one more reason also. If you take earth, no, if this is earth, and if this is atmosphere of the earth, we have different layers, correct? You have troposphere and then stratosphere, mesosphere, ionosphere, exosphere, magnetosphere. It goes on like this. Why a particular layer is called as ionosphere in area? Because it has a lot of ions, both positive as well as negatively charged ions will be here. That's why it's called as ionosphere. Now, when satellite is trying to send the signal, it may be sending 100% of the signal, but by the time it passes through the ionosphere, what will happen? Ionosphere will trap a lot of energy. And then the signal, when it reaches here, it may be around 60 or 70%. What happens? A significant amount of energy is lost in ionosphere, correct? This phenomenon is called as severe ionospheric disturbances, SID, or severe ionospheric disturbances. No wonder the GPS is becoming inaccurate, because first is ionospheric disturbance, second is satellite is getting affected by solar particles, third is satellite is also getting affected by cosmic particle. Have you understood this? Now we can structurize it, write it in answers. First is factors protecting life on the earth. Factors protecting life on the earth from particle events. Factors protecting life on the earth from particle events. Particle events, EVENTS, events. Factors protecting life on the earth from particle events. First factor is geomagnetism. First factor is geomagnetism. Second factor is atmosphere of the earth. Thick atmosphere of the earth. First factor is geomagnetism. Second factor is thick atmosphere of the earth. So these are the factors protecting life on Earth. Coming to the second one. Next topic is factors affecting. Have you written both the factors? Factors protecting life on the Earth, we have written two factors. One is geomagnetism, other one is atmosphere. Next topic is factors affecting space-based services. Factors affecting space-based services, including communication, navigation, all the systems. Factors affecting space-based services. First factor is can write solar particles or solar particle events. First factor is solar particle event. Second factor is cosmic radiation. Factors affecting space-based services. First is solar particle event. Second is cosmic radiation or cosmic particles. And then the third reason you can write severe ionospheric disturbances. Severe ionospheric disturbances. SID. You can roughly draw this diagram. After this, can you go to the next one? Okay. So far we have completed the basics of Gagan. You understood why India needs Gagan, first of all, and also why India is developing Gagan, that also you have understood, because it's an international commitment as per ICAO. And also you have learned why GPS becomes inaccurate. Clear? Yes. Some of the important tabletop airports mentioned here. So Mizoram, Shimla, Kulu, Sikkim, Mangalore, Kozhikode, Kannur. Right. Coming to the next one. How the Gagan system basically works. Told this, no? Magnetosphere is protecting. You have solar radiation and also you have cosmic radiation. Very important. This one, the ionosphere. It has more interaction, and that's why auroras generally form in ionosphere. When satellites are sending data, it will find it difficult to cross the ionosphere layer, or it will lose a lot of or significant amount of energy. Okay. To understand how Gagan works, this is how Gagan works. Initially, you won't understand anything from this diagram, but we will learn one by one. But before that, take a look at this. There are other augmentation systems also, because if India is having this problem, GPS being inaccurate because of solar particles, other countries will also have the same problem. Even though GPS is owned by US will also have the same problem, correct? So you can start writing other satellite-based augmentation systems, other SBAS. So what you can write, other SBAS, other satellite-based augmentation systems. Yeah, I'll tell you one by one. First is WAAS, all uppercase, WAAS from USA. Expansion is given in your book. You can go through it later. Wide Area Augmentation System from US. Then you have EGNOS, EGNOS, or European Geostationary Overlay Services from European Union. EGNOS from Europe. EGNOS from Europe. Then you have SDCM, System for Differential Correction and Monitoring from Russia. SDCM from Russia. And then you can write BDSBAS from China. BDSBAS from China. BDSBAS, Beidou-based augmentation system from China. Quickly looking for page number. Then MSAS from Japan, MTSAT-based augmentation system, or MSAS from Japan. Here in page number 36 in your academic book. Yeah. MSAS from Japan. The reference you can write page number 36. We're given the same map. Okay, any other doubts based on the map here? There are no augmentation systems for South America. There are no augmentation systems for Africa, Middle East, or for Australia or Southeast Asian countries, correct? Even the flights taking off or landing here should have safety. How it is ensured is, we have written Gagan belongs to India, but the footprint is larger. Do you remember the coverage area of IRNSS from east of Africa to west of Australia? The same satellites are used here also. So take a look at this. This is the footprint of Gagan. You can write the footprint of Gagan extends from Africa to Australia. The footprint of Gagan extends from Africa to Australia.